Alright, we can now proceed with our discussion of the first law of thermodynamics. But before that, we must understand one important principle in the first law of thermodynamics, which is something that we call the energy balance equation. So what does the energy balance equation mean? This means that the total energy entering the system minus the total energy leaving the system is equal to the net change in total energy. The total energy in our system. Yes. So that basically sums up kung ano yung energy balance equation. Ibig sabihin lang nito, lahat ng pumasok na energy sa system minus lahat ng lumabas na energy sa system natin ay equal sa net change in our total energy. So madali lang siyang tandaan. Basically, it's the difference between the energy entering and the energy leaving the system. So, in terms of variables, we can rewrite this para mas madali nating matandaan. The summation of the energy entering our system, which is E sub in to indicate that it's entering the system, minus the summation of all the energy leaving our system, let's say E sub out to indicate that it's leaving the system, paalis sa ating system, ay equal sa net change in our total energy. And in terms of mathematics, and lalong-lalo na sa thermodynamics, the symbol delta, which is a triangle basically, this indicates change. Tandaan nyo delta, or in the form of triangle, yeah, it's Greek letter delta. Yes, this indicates change. So, basically, that is what the energy balance equation means. And sabi natin kanina, delta indicates change. So, we also have what we call energy change in a system. Nagbabago-bago yung states of energy sa system natin. So, again, the energy change in a system, energy change, or change in energy. The change in energy is basically the difference between the energy in the final state minus the energy in the initial state. Madali lang siyang tandaan. When we say change in thermodynamics or in mathematics in general, it's the difference between the final state minus the initial state. So energy in the final state minus energy in the initial state. So this is the energy change in a system. So in thermodynamics, lagi nating makakasalubong si potential energy, kinetic energy, and internal energy, especially when we tackle the first law of thermodynamics. And nagbabago-bago sila. So again, we say that delta means change. And this means final minus initial. So, for the three types of or forms of energy that we will be dealing with a lot in the first law of thermodynamics, ganito lang yung magiging form niya. So, the change in potential energy is equal to M, diba? The change potential energy has the formula mgz, in which m is the mass, g is the gravitational acceleration, and z is the elevation of the body or the system. So the change in potential energy is basically mg z sub 2. Let's use numbers in this case to indicate that it's the final or the second state minus mg z sub 1. So that 1 indicates the initial state and the subscript 2 indicates the final state. Para mas madali natin silang matandaan, and in thermodynamics, napakahalaga ng mga subscripts kasi you'll be dealing with a lot of similar variables. Kaya the only thing that will differentiate them ay yung mga subscripts na ilalagay natin doon sa ilalim ng mga variables na yon. So this is the change in potential energy, and as you can see, common yung mass and gravitational acceleration, so we can just factor them out. So basically, it could also be written as mg z2 minus z sub 1. So yan, madalas nating makakasalubong yan. We also have kinetic energy, which has the formula, tandaan nyo na ito, 1/2 mass times velocity squared. And the change in kinetic energy is basically the final kinetic energy minus the initial kinetic energy. So that would be 1/2 mass times velocity sub 2, that is squared, minus 1/2 mass times the velocity sub 1 squared. Again, the subscript 2 indicates final and the subscript 1 indicates initial. Okay, so as you can see, common see 1/2 and the mass. So again, we could just factor them out. We will be left with v sub 2 squared minus v sub 1 squared. Okay, that is change in kinetic energy. And in our analysis of the first law of thermodynamics, napakahalaga ni internal energy. What is internal energy again? Quick recall nga, it's the energy due to the molecular vibrations in a system. So, given yung value nito, given yung value ni internal energy, kasi nagbabago-bago siya depending on the state of the system. So, the change in internal energy is basically u sub 2 minus u sub 1. Alright? We must remember that, again, delta indicates change, and it's just the difference between the final state of the energy minus the initial state of the energy. And for change in potential energy, we have this formula. For change in kinetic energy, we have this formula. And for the change in internal energy, ganun lang. Just the difference of the final minus initial. And in this case, mahalaga yung subscript. Nilagay natin na yung final ay may subscript na 2 and yung initial ay may subscript na 1. Now that we've understood this, we can now proceed with our analysis of the first law of thermodynamics. What is the first law of thermodynamics? That's right. The first law of thermodynamics is basically the conservation of energy. It's also called the law of conservation. Conservation of energy. And it clearly states, the first law of thermodynamics states that energy is neither created nor destroyed. So yan, this sums up the first law of thermodynamics. Energy is neither created nor destroyed during any process. So if it's not created and it's not destroyed, what happens? It means that it's conserved. The total amount of energy is conserved. Hindi nagbabago, walang change na nangyayari, but it only changes form. Again, the first law of thermodynamics means that energy is conserved. It is neither created nor destroyed. It only changes form. hindi nagkakaroon ng pagbabago sa amount of energy during a process. Because again, we say that the first law of thermodynamics is the law of conservation of energy. In any process, energy is always conserved. Nagbabago-bago lang to ng form. So, remember that. It's easy to remember. So, para mas madali nating matandaan, di ba, inaral natin kanina yung energy balance equation. Let's write it here. The energy balance equation is the summation of all the energy entering our system minus the summation of all the energy leaving our system. And that the difference of the energy entering and the energy leaving is equal to the net change in total energy. But again, the law of conservation of energy clearly states that energy is conserved. So meaning, walang nagbabago sa amount of energy. Yung pumasok must be equal sa lumabas. Ang mangyayari dito, again, walang nagbago sa ating system. So this must be equal to 0. So what will happen? The summation of the energy entering minus the summation of our energy leaving is equal to, again, 0. There's no net change because energy is conserved. At para mas madaling tandaan, we can transpose this sa kabilang side, making our equation that the energy that entered our system is also equal to the energy that left in our system. So basically, this sums up the first law of thermodynamics. At pag may pumasok na energy, may lalabas na energy, and they must be equal. Nagbabago-bago lang sila ng form. Kung ang pumasok dito ay potential, maaring ang maging outcome nito or ang lumabas na kasunod na form ng energy is kinetic. So, this is the summation, or basically summarizes the first law of thermodynamics. And the first law of thermodynamics varies for an open system and a closed system. Because in an open system, as we've discussed in our introduction, energy and mass can enter, di ba? But in a closed system, only energy can enter, not mass. And in thermodynamics, energy can be in 3 forms. So what are those forms? Energy can be transferred in and out of the system in the form of, first is heat, second is work, and the third is mass. Alright, so energy can enter or leave the system in the form of heat, work, or mass. So the open system and the closed system varies because of mass cannot enter the closed system. So this should be X. They only vary because they cater different forms of energy. Sa open system, pwede ang energy at mass. While in the closed system, pwede ang energy pero bawal pumasok ang mass. So to further understand this, let's analyze the first law of thermodynamics in terms of an open system and a closed system. Let's start first with the closed system. For a closed system, pwedeng pumasok si energy pero bawal ang mass. Now, applying this using the first law of thermodynamics, again, the first law of thermodynamics states that energy is conserved. The energy entering is equal to the energy leaving our system. And for a closed system, walang mass na pumapasok. But there are forms of energy that can enter, like potential energy. A closed system can have potential energy. Sub 1, since it's an initial state or it's in the entry state, plus can also have kinetic energy, can also have internal energy. And for our assumptions in our calculations, katulad ng nabanggit natin in our previous video, we will apply heat in order to produce work. This will be our assumption in every calculation or solution in the first law of thermodynamics. Let's just finish this para mas madali natin ma-visualize. So we will apply heat, which is, this is heat. In thermodynamics, Q represents heat. Okay, so those are the forms of energy and that can enter. And it can also leave our system. So we have here potential energy sub 2, final state, plus kinetic energy sub 2, internal energy sub 2, plus, since we've applied heat in our system, it must produce work. But since it's a closed system, we will classify this as non-flow work kasi walang pumasok na mass, only energy. So we have here non-flow work. So yan, that summarizes the first law of thermodynamics for a closed system. Again, Q is in the left side kasi we applied heat, and it's positive kasi nag-enter ang heat sa system. Pero kung nag-reject ang system ng heat, it will be negative. And the work non-flow is on the right side. It's in the energy leaving the system part kasi nag-apply nga tayo ng heat, may lalabas na work sa ating system. Makakapag-produce ng work yung ating system. Pero if the system receives heat or work is done on the system, this will be negative. So it's important to know the correct sign conventions. So simplifying this, transposing this to the right side, we will have Q is equal to PE2 minus PE1 plus KE2 minus kinetic energy 1 sub 1 plus U sub 2 minus U sub 1 plus our work non-flow. And again, we know that the final minus initial state indicates change. So we can rewrite this as Q is equal to delta PE plus delta KE plus delta U plus our work non-flow. And in most cases, potential energy and kinetic energy is equal to 0. So if that happens, if our delta PE, the change in potential energy, is equal to 0 and the change in kinetic energy is equal to 0, we will be left with Q is equal to the change in internal energy plus our work non-flow. So this is the equation of the first law of thermodynamics for a closed system. Heat is equal to the change in potential in internal energy, U, plus the work non-flow. Again, may pumasok na heat, makakaproduce tayo ng work, and there will be a change in the internal energy in the system. So basically, the first law of thermodynamics is energy in is equal to energy out plus the change in the stored energy, which is in this case is internal energy. Now let's proceed for the open system naman. For an open system, energy and mass can both enter the system. Pwedeng pumasok ang energy in the form of heat or work, and mass, pwede pareho, pwede silang lahat pumasok. So, proceeding, again, the first law of thermodynamics, energy in ay equal sa energy out, energy lumabas. Yan. So, katulad lang ng kanina, potential energy 1 plus kinetic energy plus internal energy. And since this is an open system, there is a working fluid. Meaning, in our previous discussion in the introduction, there is flow work. And flow work has the formula pressure times the specific volume. So, may working fluid tayo kasi may pumapasok na mass in the form of fluid, and the fluid is any liquid or gas, so there is flow work. And flow work is equal to the pressure required to push that gas or liquid times its specific volume. So this will be P sub V, P times specific volume sub 1 plus the applied heat. And we just do that on the other side, pero final states na lahat. So PE sub 2 plus kinetic energy sub 2 plus internal energy sub 2 plus flow work sub 2 plus yung since nag-apply nga tayo ng heat, we will be able to produce work, and hindi na siya non-flow kasi open system na siya. This will be classified as work steady flow. Ayan. So we have potential energy, kinetic energy, internal energy, and nadagdag lang si flow work kasi nga in an open system, mass is involved. Fluid, we have a working substance or fluid. So again, transposing everything to the right side and leaving the applied heat on the left side, we will be left with Q is equal to potential energy sub 2 minus potential energy sub 1 plus kinetic energy sub 2 minus kinetic energy sub 1 plus the change in internal energy plus yung nadagdag na flow work P sub V2 minus P sub V1 plus our work steady flow. And again, final minus initial indicates change, or we can represent them as delta. So Q is equal to delta potential energy plus the change in kinetic energy plus the change in internal energy plus the change in flow work. And don't forget our work steady flow na nag-produce ng ating system because of the applied heat. And I want to introduce you to what we call enthalpy. Enthalpy. What is enthalpy? Enthalpy is very important in thermodynamics because it's the total useful heat content in a system, especially in an open system. Ito yung nagagamit natin na useful na energy content or heat content sa system. And it's represented by the letter H, capital letter H. And it's equal to the sum of the internal energy plus the flow work. At that is the formula for enthalpy. Remember that, it's important. It's again, enthalpy is a total useful heat content, and as you can see, it is the summation of the internal energy and the flow work. And mapapansin nyo that we have here internal energy plus the flow work. And we could rewrite this as H, but since it's change in internal energy plus change in flow work, this should also be change in enthalpy. And rewriting our equation, we will arrive with Q is equal to the change in potential energy plus the change in kinetic energy, plus again, since the sum of internal energy and flow work is enthalpy, we have here the change in enthalpy. Enthalpy again is the useful heat content, and do not forget your work steady flow. And in some cases, the change in potential energy is equal to 0, and the change in kinetic energy is also equal to 0. So we will be left, matitira na lang is yung pinasok nating heat ay equal sa change in enthalpy plus yung na-produce ng open system natin na work steady flow. And for an open system, that is the equation for the first law of thermodynamics. We've applied heat to produce work, but there will be change in the stored energy in a system, and in an open system, our stored energy is enthalpy. For a closed system, our stored energy is just internal energy. So that sums up our discussion in the first law of thermodynamics. We've arrived with this. This is for open system. And for the closed system, what we've derived earlier, Q is equal to the change in internal energy plus our work non-flow. So yan, we know Now, the first law of thermodynamics. This is for a closed system. Alright?